Welcome to Study Loop.
Okay, so we've got a few Lewis structures, and we need to determine which of them are correct. I will point out that one of the problems with several of them is this. Right? Without drawing the whole thing, I'll just say that number 1 and number 2 have this problem. There's an oxygen without enough electrons, right? Oxygen is in group 6. It brings 6 electrons to the party, and it wants to have a full octet, right? It wants to see 8 electrons. This oxygen does not have a full octet. It's seeing 2, 4, 6. And if you calculated its formal charge, if it's only seeing 1 electron from each bond and 2 electrons here, this would be oxygen 2 plus, right? So those aren't correct Lewis structures. 1 and 2 both have that problem. Okay. 3, all right, the problem is that we have no lone pairs on oxygen, right? We need 2 sets of lone pairs, 2 bonds and 2 sets of lone pairs on oxygen for it to be neutral. All right, so 3 is also not good, but 4 is okay because, as you'll notice, it's got 2 bonds and 2 lone pairs. That's 2, 4, 6, 8 electrons. And when we calculate its formal charge, we get 1 from each bond, 1, 2, and then 2 from each lone pair, 3, 4, 5, 6. And if it's in group 6, and we subtract the number of electrons it sees in that way, we get 0. That's neutral. That's good. So 4 is the answer, or D. Okay. There's some other problems on this sheet. We're looking for constitutional isomers, okay? And so we see 1 carbon, 2 carbon, 3 carbon, OH, all right? We see 1 carbon, OH, 3 carbon, okay? We see 1 carbon, 2 carbon, oxygen, 3 carbon, okay? And then the final one is dimethyl ether, okay? So notice we have 1, 2, 3 carbons, 1, 2, 3 carbons, 1, 2, 3 carbons, okay? And then here we only have 1, 2 carbons. So this one's no good, right? And then we'll notice that there's, in terms of hydrogens, 3, 2, 2, 1, right? So that's a total of 3, 5, 6, 7, 8. Okay, 1, 2, 3. 1 here, that's 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8, right? And obviously we have 1 oxygen for each of these as well, right? So these 3 are all C3H8O, right? So they're constitutional isomers. So the answer is 1, 2, 3. And that is C. Okay. And then statements about resonance. Which of the following is incorrect about resonance? Movement of electrons from one form to another. That's true. Right? If we have something like this, right, that's the movement of electrons. Okay. Oops. Resonance structures are not isomers. Yeah, that's true. They're not isomers. They're the same molecule. Okay, so far A is okay, B is okay. C, resonance structure differ only in the arrangement of electrons. True, right? These are the same exact structure except for where we have this double bond, right? C is true, and then D, resonance are in equilibrium with each other. This is not necessarily true, right? Because as you may know, it's actually that the true structure is a hybrid, right? And we draw two different structures and say that it's in equilibrium. But in actual fact, we get something like this: a resonance hybrid that's a time average of the two structures. So they're not technically in equilibrium with each other. So D would be the answer.